Okay, so today it's our last section of the chapter. It's inverse relations and functions. We're going to represent inverses in different forms. And then on Wednesday, we are going to find inverses and verify inverses. Good?
No.
Yeah, we're going.
Okay, what is an inverse relation? What is the inverse relation? Inverse of the relation represented on the table. I cannot talk. So in inverse switches, so what is an inverse? So you might want to write that, right? Inverse functions switch range and domain in IE, otherwise known as what's another name for range and domain? X's and Y's. I said range and domain, so that probably should be Y and then X, but does it matter? No. Okay, so if I call this function f of x, actually I don't know if it's a function, we haven't done that yet. So if I call this y, then y prime would be its inverse. So what would the new x and y be? We have negative 2, 1, so it's going to be what? Nope. It switches the domain and range. 1, negative 2. Negative 1, 4. So it would be what?
4,
I have 0, 3, so it'd be...
3, 0.
And 1, 1 would be? Do the next one on your own.
So you just switch them?
Mm-hmm.
Yeah, I know it's not this easy.
You're just gonna throw a
This
curveball.
part is. This part is easy.
And actually, she's going to tell us to put in 16 different formulas.
Put it back.
Can you guys knock off the attitude, please?
Yes, ma'am.
Oh my gosh. Oh no, I did that right.
Did you get it right?
No, I'm not even doing that.
Cooper, did you get it right? Austin, did you get it right? Okay, questions? Got it? Okay, to find the inverse relation of an equation, interchange x and y and solve for y. So it says find the inverse of f of x equals x squared. So what does it say to do?
Interchange X and Y.
Interchange x and y. Well, I don't see an x, do you? What up there? I don't see a y, do you? What up there means y? F of x is the same as y, correct?
Mm-hmm.
So I need to interchange these things. So it's going to be x equals y squared. That's all you do. And then it says what?
Solve for y.
Solve for y. So how do I solve that for y?
Square root of both.
Take square root of both.
Yeah.
Okay, so I get y equals
Square root of,
the square root of x.
yeah.
Okay. And it's actually plus or minus the square root of x, isn't it? When you take the square root of something, isn't it plus or minus? Yes. Okay, it says, what does our graphs look like? Well, what does the graph of x squared look like? It's a parabola with the vertex at 0, right? It's the parent function. So it looks like this. Okay. Well, what does the square root function look like? We've graphed that. What's it look like? Half of a parabola, right? But on its side. So the positive would look like this. Yes? Well, what would the negative do? Reflected across the x-axis, wouldn't it? So it would look like what? Now, if you notice, they have this like space, right? I'm gonna circle it and then I'm gonna erase it. Right in here, they cross each other, don't they? Yeah? Well, what happens when you graph an inverse, they reflect across the y equals x line. So that means a y-intercept of 0 and a slope of 1. It's called the identity line, that y equals x. So it starts at 0, the y-intercept 0, and has a slope of 1. Are these two graphs reflected across this line? Yes. And that's what all inverses do. Every single inverse reflects across y equals x. Every single one. As long as you find it right. Austin, tell me when you're good. Alex, stop, please. Thank you. Okay, so again, I just put the directions there. It says to find it, we interchange x and y and solve for y. So what would my new equation be? Because this is y, yes?
So that would be x equals 2y plus 1.
Okay, so x equals 2y plus 1. And then I have to solve for what?
Y.
Y. So how do I solve for y?
Subtract the 1 over.
Subtract the 1 over
Which equals 1/2 x.
and divide everything by 2. So y will equal 1/2 x minus 1/2. So it says, what does the graph look like? Well, it has to reflect across that xy line, doesn't it? So we're going to graph it. I need to make some marks on my graph because this one I can graph pretty good, I think. I mean, it's just y-intercept and count the slope, right? Okay, so my first equation, the y-intercept is 1, and the slope is up 2 over 1. So I could also go down 2 and left 1. So my first one, that, right? What color? Blue. So my next one is y-intercept is -1/2. So that would be probably right there, wouldn't it? And then up 1 and right 2.
You went up 3 on the first one.
No, I didn't. From 1, I went up 2.
That'll be over. Never mind.
And then I go, oh, my over isn't right on that one because I'm a half. So that'd be 1, 2. So it'd be like right here.
Right on the x-axis.
Huh?
Right on the x-axis.
I don't know. That's a good question. Very good question. Because it's a y-intercept, right? Okay, so let's try this again. So up 1 and over 2. And then down 1 and over 2. Something's wrong.
What did those points touch?
No. Why did I say something's wrong? What line should it reflect across? The x equals y, right? So it should be like the line should go here, 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 here. Like it should reflect across this line, right?
Wait, isn't it a -1/2?
Yes, it is. Thank you very much. I said, what I do wrong?
Yeah,
Okay. No, Olive's right. Okay, so -1/2. So I go down 1 and left 2. And up 1 and left 2. But did you see how I I graphed that and it wasn't like, we had it wrong. I still feel like something's wrong. X up 2 over 1, right? Down 2, left 1. Other than it's not right on 1, is it? It keeps jumping to that point. That's funny. Wonder if it wants a point. So, what's wrong with, why do I keep saying there's something wrong? Can you guys see why I'm saying there's something wrong?
Because it's not reflected over that line.
Yeah, I wonder if we're just graphing bad. Or I'm graphing badly.
That middle point looks funny to me. You're still going from a +1/2.
I thought you were like my slope was negative. Oh my gosh.
No.
I give up. It's been a bad day, evidently.
Yeah, me too. It's okay this week. We can have a bad day together.
We can have a bad day together. Thanks.
Anytime.
Okay, so half. Up 1, right 2. Yes? Down 1, left 2. Let's see if it can actually work this time. I think it's going to work this time because I remembered Olive kept pointing out what actual slope was because evidently I've seen too many wrong slopes. Now do we have it? Okay, here's 0, 0. And then we're just going to come to this one here because it likes to jump to points, which is weird. So now is it reflecting across this line.
It is.
Now the pink one's a little off, but you can see what happens. You can put them in your calculator and see it a little clearer. It'd be actually a lot clearer in your calculator, wouldn't it?
Mm-hmm.
Yeah. You all have calculators. Let me open my calculator. So I'll need you guys to give me the equations when it decides to open. Okay, so I would go to y equals, right? And what was the first equation? Y equaled, what was it?
One, 2, y plus
No, the very first equation. F of x equaled
1. X squared.
2x plus 1. I thought you said something else. Okay, plus 1. And the next one was 1/2 x minus 1/2. So zoom 6. Oh, you know what I want to put on there? I'm going to put on there that y equals x line. That might be helpful, right? So you can see it. So now did it reflect across there really nicely? Every time it should happen. Every time. So the last one we had it was x squared, right?
Yeah, x equals x squared.
And then we had negative the square root of x. And then we have positive the square root of x, right? And I'll make that red also, so it looks like one graph. Oh, I got it. I keep trying to just like punch the key, and I can't. Like my screen, not the key. Now you can't really see it, but what if I zoom in? Can you see it reflect across that line now?
Mm-hmm.
Okay. It just kind of,
No, it doesn't.
I think it does.
No, it doesn't.
It does. Okay, so let's see what else we got to do today. Okay, remember for a function's inverse to also be a function, it has to be 1 to 1. You might want to write this down. So for a function's inverse on your notes, for a function's inverse to also be a function, the starting function has to be 1 to 1. And 1 to 1 means for every, I got a arrow. For every x, there is only one y, and for every y, there is only one x. We've learned to say if something's a function with our vertical line test, right? If it hits it more than once, it's not a function. Okay? So if I did a vertical, and a function means every x has how many y's? 1. But this one says for every y, there's only how many x's? 1. So if I were to do the vertical line test, would this pass? Can you even see that pink? You can't even see that pink. If I did the vertical line test, does this hit it only once every single place?
Yeah.
Yes. So it's a function. Yes? But if its inverse is a function, it has to pass also the horizontal line test. What about this? Does that pass it?
Yeah. Oh.
How many times can it hit if it passes? Once. And how many times does this hit? Twice. Remember when we drew that inverse? What did it look like? Because we already did the inverse of this. What function is in the blue? What function is that?
F of x equals x squared.
Right. F of x equals x squared, because it is a function. Ooh, that's not what I wanted. Still not what I wanted. So this is f of x equaled x squared, right? What did its inverse look like? Like this, didn't it? Now, for its function, to its inverse to also be a function, it has to pass 1 to 1. Well, we already established it wasn't 1 to 1, right? And is this a function? No, because it fails the vertical line test. So sometimes people say, well, not everything has an inverse. Everything has an inverse. Not everything has an inverse function. Does that make sense, what I just said?
Yeah.
So why f of x equals x squared has an inverse, but is it an inverse function? No. Okay. Could I do something to the blue to make it have an inverse? Could I do something to it? Like, could I limit its domain to have an inverse?
Yeah.
How?
Make it shorter.
Like how? Because right now the domain is all real numbers. Could I do something to make it pass the horizontal line test? Look at the picture, not me. How could I make that pass the horizontal line test? Get rid of what?
The square?
On the graph.
Oh, well,
What could I do to the graph to make it pass the horizontal line test?
Move it so it's only on one side of the x-axis.
Well, if I moved it left or right, it still wouldn't pass the horizontal. Could I do this?
Like that, like shrink it so there's only one.
Would that pass the horizontal line test? It would, wouldn't it?
Sure.
So my domain isn't all real numbers there. I made it all numbers less than what?
0.
0. So I changed the domain so x such that x is less than or equal to 0. I could do that, right? Well, I could also do what? Make it what? Greater than 0, couldn't I? So I could limit the domain, and the inverse of what I have there would just look like this. Now, is that a function? Yeah. And if I left the other half, let me make it red. If I left this half, its inverse would look like what? That. Now, it's not perfect, but is that still reflecting across that line? Yeah, it just looks weird, doesn't it? So if we limit our domains, we can make any function have an inverse function. We just have to limit that domain. But in general, does y equals x squared have an inverse function? No. But I could take its domain and do some stuff with it to make it have one. Okay, find the inverse function of each of the by identifying the appropriate restriction on its domain. So,
7.
well, no. You can't just say 7.
Close.
Okay, so the first thing we should probably do is, I think factoring it might be the best thing, don't you?
yeah.
Yeah? Because I can find the zeros and then I could picture the graph, couldn't I? Yeah? Okay, so factors of 16 that add to 8.
4.
So it'd be x plus 4 and x plus 4.
Yeah.
So my x-intercept would be x equals negative 4. But it would have a multiplicity of 2, meaning the graph does what at that point? If it has an even multiplicity, what does the graph do in a 0? Does it go through it? It bounces, right? So this graph goes to negative 4, right? And then goes up. So what would I have to do to its domain to get it to pass the horizontal line test?
Make it positive.
No, it's not what we did with the last one. I took off part of it, right? And it hit 0, so we said less than 0 or greater than 0, but we're not at 0 anymore. Where are we at?
-4.
-4. So what do you guys want to do, though? Less than -4 or bigger?
Bigger.
Austin, what are you doing?
I don't know. That's on the graph.
Please don't mess with the table.
What a good guy.
Okay, so we're going to restrict the domain. It started off to be x such that x was all real numbers, right? And that's not going to work for us. So what'd you guys say, bigger there or less than?
Bigger.
Bigger?
Yeah.
So we want x such that x is greater than or equal to -4. So that means we're going to get rid of all of that. Is that 1 to 1 now?
Yeah.
What does 1 to 1 mean?
1 to 1.
What does it mean?
That's what I mean.
Every x has how many y's?
1.
1. And every y has how many?
X.
X's.
That's 1x. It means it passes both the vertical and the
Horizontal.
horizontal line test. Okay, so what are we going to do the next one?
Thank you. Just stay there. Thank you.
Isn't it just X minus 3 is just
Okay, so we're going to factor it. So x minus 3 and x plus 3. So that means x equals plus and minus 3. Doesn't it? Okay. That's a weird color. So we're 1, 2, 3, 1, 2, 3. So I have a 0 here and a 0 there. We know that it opens up because that's positive, but we need to know its vertex, don't we? Yes. So you have 2 ways you can find a vertex. Anybody remember how to find the x value of the vertex?
No.
Nope.
X equals -b over 2a. Yep. It's the first part of the quadratic formula, isn't it?
Oh no.
Yes.
Yeah.
Or you can find right in the middle of the 2 and use it, but we're going to use the -b over 2a. So what's the b value? 0. So 0 over 2 is what? 0. Is 0 right in the middle there?
Yeah.
Yeah. And if I plug in a 0, I get -9. So I really didn't care that it was -9, but it's good for us to remember how to graph it. Okay, so now what do we need to do the domain to make it have an inverse? Because it passes the vertical, it does not pass the horizontal. Not every y has 1x. If I ask you when y is 3, you'd have to tell me twice, wouldn't you? Because it's on the left and on the right. So it's all real numbers now, like this one. So what's our value? This one was -4. What's our value going to be on this one?
3.
What's our vertex? Where's the middle? 0. So it's going to be x such that x and 0. So you want it greater than or less than? Greater than? So greater than or equal to 0. So that means I got to get rid of what?
The left side.
And now, does that pass both the vertical
Yes.
and horizontal? So if I told you to graph its inverse, could you kind of imagine what it looked like? So it would go, this one goes through -3, 0, so I'd switch that, and it'd be what? -3, 0, 0, -3. So go through right here. And this point is 0, -9. So what would 0, -9 become? -9, 0. So it'd have to go through both of those, right?
Yeah.
And I go like, my brain is shut think I curved that wrong. Domain is y. Oh, I put it on the wrong side. Wouldn't it have to go this? Have to go this way.
Yeah, it would.
Oh, we said 0, -3, but it should be 0, 3. Yes? Not -3. I let you say it and I didn't catch it. Now does that reflect across this line? Did you see how I said, oh wait, there's a problem? Because did it reflect across that line? No. So do you have like an ultimate check on that? Yeah. Should you put this in your notes and remember that's how to find a vertex of a parabola? Right? And it's only x value. How do you find the y value? You plug it back in, don't you?
Always something.
Is it negative here?
Yep, -b over 2a. Okay, am I good on this?
Yeah.
I used some weird colors on that slide. Okay, find the inverse of each. So how do you find an inverse?
You flip the X and the Y.
Flip the x and the y. So that's going to be x equals the square root of y minus 2. So how do I get rid of the square root?
You square it.
Square it. So I have x squared equals y minus 2.
Minus 2 divided by
Add the 2 over.
X squared plus 2 equals 1.
Now, this function here, because this is a parabola, isn't it?
yeah.
Okay. And we want it to be a function, and it is. And we should write it as f of x inverse. That -1 means inverse there. But this is a square root function, yes? Yeah? That's vertex goes from 0, 0 to 2, 0. So it goes 1, 2, it starts here and goes like this. Yes? That's what that square root looks like. But our inverse is a parabola. Does a parabola look like what we have? No.
I thought the parabola was the curve.
A parabola is, what we have here is this. Does this look like this? No. So we have to do, we can't have all of it. We can only have what?
Half.
We could only have half of it. So we need to figure out which half we have.
Top half.
If we have, because this graph right here, it goes up 2. Yes? We got to use all those skills we've been working on all year. So it goes up 2. Well, that makes sense because this orange point is 2, 0, so this one has to be 0, 2, doesn't it? Yeah? And then let's figure out, like, if I put in 4, what would it be in this graph? So if I put a 4 in here, oh, we don't want to do that. We want to put a 6 in there. Why do I want to put 6 and not 4?
Because 4 is 4.
Well, 4 minus 2 is 2, and then I'd have the square root of 2. Do you want to do the square root of 2?
No.
No. I want to do the square root of 4. So if we put 6 in here, so if I do f of 6, 6 minus 2 is 4, square root of 4 is 2. So I made my graph too high, didn't I? So here it'd be right here. So it would go like that. So we interchanged 2, 0 to 0, 2. Well, what would 2, 2 change to? Oh, no, 6, 2. Because this is 6, 2, isn't it? It would become what? 2, 6? So I need more stuff up there, don't I? So it'd be 2, 6. So this graph would go. So what does my domain have to become on this inverse to give me this green? Can't be all reals, can it? What am I putting, what kind of x's am I putting in here to get it over here? What x's are being used?
Positive.
All the positive, right? So the domain here would be,
Less than.
no, it wouldn't be less than. Less than would give me,
Negatives.
oh, I get what you're saying. No, less than wouldn't give me negatives because it's squared. So is it everything going to give me positives?
Yeah.
It's all going to give me positive y's, right? But I want y's that are on, because y's go up, right? But I want y's only on, so I could only go, my brain is like, blah, blah, blah. So x has to be greater than equal to 0, right? Nothing's going to give me negatives, but I could only put positive x's in there because I don't want y's on the other side of the y-axis. Do I? Does everyone get what I'm getting at? Because if I put into the inverse, if I put -2, I get 4, I get 6, don't I? But that point is where? It's over here. Do I want anything over there? No, because then it wouldn't pass the horizontal line test, would it? So the hard part isn't finding the inverse. The hard part is thinking about the domain, isn't it? Is that going to take you extra practice? Okay, so I have f of x equals negative the cube root of 4x. So what's the first thing I do?
Cube it.
Nope. Before that. Very first step.
Inverse.
Switch them. Switch the Y's and the
Switch the y's and x. So x equals negative the cube root of 4y. Nope, I forgot my cube root, didn't I? So how do you get rid of a cube root?
cube it.
Now you cube it. Actually, probably, I think we have to take care of that negative first, don't we? Because it's outside of there. So that would be negative x equals the cube root of 4y. Does that make sense what I'm saying? Because it was outside. So now I have to cube it, and I need to make sure I put parentheses around this negative, don't I? Okay. So I have negative x cubed equals 4y. Divide by 4. So y, can I just put 1/4 instead of putting divided by 4? Is that okay?
Would it be negative?
It's going to be negative x cubed. And I made you think about the square root because you know what a square root looks like. That's why I made you look at it. I will tell you that a cube root, we haven't really done anything with them, but they look kind of funny. They look like this.
Ew.
So is that 1 to 1? Does it pass the vertical and the horizontal?
Yeah.
Yes. How does it not?
Yeah, it does, right?
Yeah, it does, right? So it's inverse. Not even knowing what that graph looks like, I know that inverse has to, like, mirror it, don't I? So it has to look like what? That, doesn't it? That's kind of weird, isn't it? Can you put these in your calculator to check them? Yes. And I think we got through everything. Oh, just more examples. I think that's the last. Oh, verify. You didn't get to verify. You do have everything to do today's assignment and to start Wednesdays. So if you know you're going to be gone, that might not be a bad idea. Because then you can ask questions tomorrow. When you guys get back. I think you'll be back IAP-ish. So I would work, if you're going to be gone, you two going to be gone Wednesday, I would try to work on both assignments tonight. So you can get started and ask questions, and then maybe during IEP I could show you what you need for the rest of it. Or after school or whatever, it wouldn't take very long.